Hi, and welcome to MSc. In this video, we're going to look at two ways of rationalizing the denominator. So to fully understand this, we need to recall that it's convention to not leave a negative sign in the denominator of a fraction. So you might have been told in the past, if you had a fraction that was 3 over negative 4, that you should rewrite this as negative 3 over 4. And that it's convention to move that negative sign up to the numerator. Really, when we're doing this, what we're actually doing is we're multiplying both the top and the bottom of this fraction by negative 1. And by doing that, this fraction that we're multiplying by actually has a value of just 1. So we're not changing the value of the fraction. And so 3 times negative 1 is negative 3, and 4 times negative 1 is 4. We can also think about this because division of a positive by a negative makes a negative, and so it doesn't matter which one is actually negative. And sometimes in this case, because of that, we'll actually see the negative sign right out front of the fraction, as opposed to just being with the numerator. Regardless how you picture this, it is convention to not leave the negative sign in the denominator, but instead write it in the numerator. And so a similar mathematical convention occurs when we write radicals in the denominator. And it's convention to not do that, to not have radicals in the denominator. And we call this rationalizing the denominator. Because of course radicals, square roots specifically, are all irrational numbers unless they are perfect square numbers themselves. That is, they are non-repeating, non-terminating decimals. And we don't want to leave those in the denominator of fractions if it can be avoided. So there are two main scenarios to rationalizing the denominator. So let's look at a couple examples. This first one has one term, radicals, in the denominator. And the way we do this is very similar to what we did to get rid of that negative in the denominator. What we do is we're going to multiply it by a fraction, where the value of the fraction is just going to be 1. So I'm not changing the value of my overall fraction at all. Well, I know how I can get rid of this square root. I can square it. But of course, that changes the value of it. But let's just try thinking along those lines and saying, well, what if I multiplied the denominator by root 7? That's certainly like squaring it, and it's going to get rid of the radical. But I need to make this fraction have a total value of 1, so I don't change my fractional value. So if I multiply top and bottom by root 7, this will hopefully rationalize the denominator and get rid of this irrational number and move it. So 4 times root 7 is just 4 root 7. And root 7 times root 7 is going to be square root of 49, which by design, this we'll leave the denominator at just 7, and we have successfully rationalized the denominator. So to rationalize the denominator, we are just going to multiply both top and bottom by the radical that you see in the bottom when there's just one term. Okay? On the other example that we have over here, we can think about doing the exact same thing, multiplying top and bottom by root 8. However, you might notice that root 8 can be simplified before we even start. And we don't have to do the step at the start. We can do it at the end as well. But we might as well get that done early. So let's simplify this to start. Root 8 can be simplified to root 4 times root 2. And root 4 is just 2. So it'll be 5 minus root 5 over 2 times the square root of 2. Again, if you've not had a chance to look at my videos on simplifying and adding and subtracting, multiplying, dividing radicals, I fully suggest you pause this video and go check those out first, because that's essential learning before you can fully tackle what we're doing here. So now I've simplified, and I can see I have a radical in the denominator. It's not going to be wrong to multiply top and bottom by 2 root 2, but we don't need to. I can get away with just picking on the radical. So I'm going to multiply top and bottom of this fraction by root 2, and by doing so, I'm essentially just multiplying this fraction by 1. The whole purpose of this is just to change how it looks. So this root 2 needs to multiply both pieces in the numerator, which is different than what we saw in the past example. So we're going to have 5 root 2 minus root 5 times 2, which will be 10. Then in the denominator, we're going to have 2 times root 4, 2 times 2. And again, that was by design, so that the denominator will produce a rational number. We're going to have 2 times 2 in the denominator. In the numerator, it is convention to write the larger radicals first. So we'll flip the order around to the numerator and write the larger radical first. Many teachers, that might not matter to them, but it is a convention to write the larger radical first. So that's what we'll do. And then the denominator just becomes 4, and there's no other reducing that I can do at this stage. But the denominator has been successfully rationalized. Okay, so always check and look for ways to reduce the fraction, or reduce the radical rather, before you start. And then we're multiplying top and bottom by the radical that you see in the denominator. Now this method only works when there's one term only in the denominator. So if we go to an example where there's 2 terms in the denominator, we need to do something a little bit different. However, we are still going to multiply by something that is the equivalent of multiplying by 1. So it's going to be the same in numerator and denominator. Otherwise, we're changing the value of the fraction. And the trick to doing this, when there's 2 terms, is to multiply by the same terms with the opposite sign. This is called the conjugate. And a conjugate has the same 2 parts, but with an opposite sign in between. So if we multiply top and bottom by the conjugate of the denominator, that will rationalize the denominator. So let's take a look at this. In the numerator, the 6 has to get distributed to both. So we'll do that part, and we'll say 6 times negative 6 root 3. And in the denominator, I need to fully FOIL this out completely, right? So we have the 1 multiplied by both parts. So we'll do that first. So this will be 1 times 1 is 1, 1 times negative root 3. And then we have to repeat the process for this root 3 and multiply it by both of the others. So positive root 3 times 1 is plus root 3. And positive root 3 times negative root 3 is negative root 9, which we could just write directly out as a whole number, but I'll show it like this for this video. So the numerator is nothing else I can do. Those aren't like radicals. And in the denominator, you'll notice that the 1 is just a whole number. And positive root 3 and negative root 3, well, those will cancel. So you'll always get these middle terms canceling when you multiply by conjugates. Then we'll have negative root 9, which is 3. So let's simplify this. In the numerator, we'll have 6 minus 6 root 3. And in the denominator, we'll have negative 2. And remember, we also don't want to leave negatives in the denominator as well. So let's see what we can do here. Well, the negative 2 actually divides evenly into both of the 6's. So 6 divided by negative 2 is negative 3. And negative 6 divided by negative 2 is positive 3, root 3. So by rationalizing this denominator, which now has a denominator of just 1, which we don't write, we actually got rid of the fraction altogether, which is great. So let's try this again on this other example, and I encourage you to try pausing the video, trying it on your own, and then checking your answer. I'll run through this example fairly quickly. The difference on this one is that we have a radical in the numerator as well. So I look at the denominator. I see 2 and 3 root 5. I see it's negative, so I want to multiply by the conjugate of that. So that'll be 2 plus 3 root 5. And I'll multiply top and bottom, so this fraction has a value of 1. I'm not changing the size of the fraction, just changing what it looks like. And then we're going to distribute. Root 2 times 2 is 2 root 2 plus root 2 times 3 root 5 is 3 root 10. In the denominator, we're going to have 2 times 2, which is 4. We're going to have 2 times 3 root 5, which will give me 6 root 5. And then we'll have the negative 3 root 5 times the 2. Don't forget that negative. And that's going to give me negative 6 root 5. And we'll also have negative 3 root 5 times positive 3 root 5, which will give me negative 9, the 3's multiply, root 25, which we know is just going to be 5. But again, I'll list it like this for now. In the numerator, there's nothing I can do at this moment in the numerator other than perhaps reorder things to put the larger radical first. So I will do that. Again, I haven't changed anything, conventions to put that larger radical first. There it is. In the denominator, we notice, just like last time, as predicted now, those middle terms cancel. And the conjugate did that for us, which is great. I have 4, and I'm going to have negative 9 times 5, because the square root of 25. So I have 3 root 10 plus 2 root 2 all over 4 minus 45. And so I'm going to have 3 root 10 plus 2 root 2 all over negative 41. And if you're not careful, you'll think you're done this question because you've rationalized the denominator, right? We got rid of the irrational root 5 that was down there originally. But we have this negative down there, so we should bring that to the numerator. And we can think about it coming up and multiplying everything in the numerator, or if you like that idea of multiplying the top and bottom by negative 1, that's really what we're doing. And so a really common mistake here, without really thinking this through, is to make the first term negative over 41 and then write the positive here. But it's not, because this negative applies to everything. So it will be negative 2 root 2. So these are interesting problems. They practice some fraction work. They practice reducing fractions. They practice multiplying and adding and subtracting radicals. But the key thing is we can rationalize the denominator. We can get rid of radicals in the denominator by multiplying by the radical when it's just one term in the denominator, top and bottom of the fraction, or when we have two terms in the denominator, like we did in these examples, we multiply by what's called the conjugate. And we do that to the top and bottom so that we don't change the size of the fraction itself. I hope you found this video helpful. If you have, please consider liking and subscribing. But as always, thank you very much for listening and watching.